Hello, everyone, and thank you for joining today's webinar, Integrated Engineering 101, Mechanical, Electrical, and Automation Remote Collaboration. Please note that you have joined as an audience member and are muted. My name is Madeline, and I'm today's moderator, and I'm joined by Dan Turk, Application Engineer and Resident NX and Solid Edge Guru, and Curtis, our Director of Technology. He'll be joining us at the end for questions. We're going to get started with a quick overview of our agenda. We'll get started with a little bit about Geometric Solutions, who we are and how we can help you. Then we'll jump into our main topic, MCD. Specifically, what is MCD? How can it be used with non-Siemens hardware? And how can it save your company a lot of time and money? Our presenter today is Dan Turk, Application Engineer at Geometric Solutions. Dan has had experience in a variety of industries in his 20 years. From automotive to consumer products to medical devices, he's seen it all. He is an expert with NX and is rated as one of the elite 100 users in the world. He has taught NX at both small companies and Fortune 500 companies throughout the US, Europe, and the Far East. As for a quick intro to who we are at Geometric Solutions, the Waltonen family is made up of 3 companies throughout the Midwest: Waltonen Engineering, Independence Tooling, and Geometric Solutions. Our story is simple. Waltonen develops innovative engineering solutions using Siemens software. We got so good at it, Geometric Solutions started selling the same potential for success in the form of Siemens software. So when it comes to implementing and optimizing these solutions like an expert, Geometric Solutions can get you there. Now I'm going to pass it over to Dan. Dan, take it away.
Thanks, Madeline. So to start with, we're going to talk about NX MCD, or Mechatronics Concept Designer. Really, what we could think about this as is it's out with the old and in with the new. When we think about engineering as an industry, what have we done? Well, we've gone away from the old. We're no longer using drafting boards. No, we're using computers. We're using simulation, digitalization. We're using digital twins. But when it comes to machine builders, how can we get out with the old and how can we join the new century? How can we get in with the new? Well, really, what it is that digitalization, it changes everything. It's no longer just about making a prototype and hoping it works, but no, we're building entire machines. And it's no longer that it's just a mechanical machine. No, now we have electronics, we have automation, we have software, we have so much more that is put into it. Digitalization changes everything. And that's why you're attending this webinar today, so that you can stay ahead of the curve. Now, the market trends, likely you found this to be the exact same challenges for you, is that you need to decrease the amount of time it takes to get your machine to market. And you need to do this in order to be competitive. It's almost like all the machine builders, they're in a race to see who can get things done the quickest. But at the same time, these machines, they have so much more to it. Again, it's not just mechanical anymore. Now we have software, automation, and all sorts of extra things. So machine builders, they're trying to find ways to reduce the costs of the engineering process. One way to do that is to reduce the amount of time it takes to design, develop, and build a machine. But at the same time, your customers and you yourselves, you're not going to be happy having a machine that's made quickly, but it's not a high quality product. And when it comes to these new machines with all of this new software, electronics, how are these engineers going to be able to work together? And then how can we verify that the machine that we've designed, how can we verify it's going to work once we've created it, once we've started cutting metal? Again, this is the key benefit of NX Mechatronics Concept Designer, or MCD for short. It's been found that if we use NX MCD throughout the entire design process, we can save about 33% of time and of costs. Put another way, you can be 33% faster than your competition, or you can beat your deadlines by a third, or you can take on that many more jobs. With MCD, we're able to start with the concept and actually have a really intelligent one. We're going to look at that in depth. We can also take mechanical, electrical, automation. We can take those engineers and they can be, as it were, in the same room and they can work together. And lastly, instead of just having real commissioning, we can do virtual commissioning. Before any metal is cut on your machine, you can verify that it's going to work. And that goes for mechanical, electrical, and automation. And we'll look at all three of these phases in more depth. So this is a typical path that we would take to make a machine. So the old way, the past, we'd start with requirements, and then it would come to a concept. Now what we see there is kind of like that cocktail napkin, where we just draw up a concept and we're hoping that this is going to work. When it comes to detailed engineering, ideally, there's some overlap. Mechanical usually gets started first, and then electrical comes afterwards, and software, they come at the tail end. Lastly comes the commissioning. This is real commissioning. And typically this commissioning is going to happen somewhere else than your facility. It's going to happen maybe in some plant in one of the far-flung corners of the globe. This is a problem with the pandemic that we're currently facing. Well, how are things happening today? What is the now? Well, we still start with requirements. But then when it comes to a concept design, it's not just a cocktail napkin. No, it's a design that has intelligence built into it. With detailed engineering, we're able to have mechanical, electrical, software. They actually get to work together. And then when it comes to commissioning, we can have virtual commissioning. That's right. You're going to get to see today how you're able to commission a machine before it's even built, before a single piece of metal is cut, before a bolt is turned and tightened, you can commission it. And then lastly, there's still some real commissioning that would need to be done. Basically, that has to do with making sure that everything is tweaked just so. In doing this, we can save up to a third of the time throughout this entire process. So how many more projects, how many more machines, how much further ahead will you be with NX MCD? So let's look at these one at a time. The first is the concept phase. You've got an idea, and maybe it is a cocktail napkin. Well, let's have our first poll question. We're going to poll each one of these three categories. So our first poll, what best describes your concept designs?
It looks like our top answer was one concept after another after another.
Yep, that sounds about right. It looks like at least somebody voted for a home run every time. Whoever did that, please send us your resume, because that's pretty rare that you can get it spot on every single time. Really, that's the answer we expected, was one after another, because we have an idea, but then we're going to try some other ideas, and we're just going to wait and see which one is right. Now, this is where MCD is very helpful, because we don't have to spend a lot of time creating a concept to validate it. Let me show you what I mean. Here we've got this little stick model. It's just a sketch. Literally, it's just a couple of lines. How long would it take to make these little lines here? And not long at all. And yet we're able to see, is the idea that we have, is it going to work? Can it go from the napkin to the computer to reality? Because with MCD, we're able to take stick models, little lines, and really get some information out of them. We can estimate the load of individual joints, and we can take this design and use it further down the road. So with the concept, you can take something simple and easy and validate it. Let's look at our next phase, detailed engineering. And we're going to have another poll here for everyone. So in your department, when it comes to engineering, who comes first? Mechanical, mechanical, or mechanical? Let's go ahead and launch that second poll. And you can kind of see where I might be a little biased.
Surprisingly, our top answer is mechanical engineering.
You know, I'm not sure if I was kind of pushing people in that direction or not, but that's what we're finding when we talk to different companies, different customers about NX Mechatronics Concept Designer, is we're finding that mechanical comes first, and then electrical and automation, they're just getting squeezed in at the end. Now, myself, I am a mechanical engineer, and I will admit that the next group, we would just say to them, well, you're just going to have to wait your turn. But with NX MCD, we can get away from that because we're able to have electrical, mechanical, and automation, we're able to have them work together. Some of the cool things about MCD is its real-time kinematics. If you have a machine that needs to have synchronized movements and it's got all these different axes, well, it can create cam curves for you. There's also a powerful physics engine built into MCD, and there's workflows for ECAD, so for the electrical guys. And then we can also take and create a sequence of operations, and that will help automation programming. Really, the idea is that everybody gets to work together. And this is going to decrease the cost and design time. But also, it's going to make for a better product because we're not rushing at the end. We're not forcing the automation guy at the end to have to hurry up and get his part done. That brings us to the third part, commissioning. With MCD, it's virtual commissioning. Let's have our last poll. Where are you doing your commissioning?
Looks like our top answer is in our facility.
All right, that's interesting. Yeah, when it comes to the commissioning, a lot of the customers that we spoke to, it's similar to what we're seeing in these poll results, that they're able to do some of it in their facility, and then the rest, they're having to do it at their customers. One group that we spoke to last week, they talked about commissioning and how they're trying to do it. And they said that when they get to their customer's facility, they are dead on with their commissioning, with their programming, 5% of the time. That was pretty surprising because it was a successful company. But when it comes to commissioning, how can we speed up this process? How can we make it so you're not having to spend so much time in one of the far-flung corners of the globe? Well, that's where virtual commissioning comes into play. And with NX MCD, we have some scalable different options. We can start automating our program or writing our program really early in the design phase. We can do all of this before any metal is cut. But even as you're noticing in these pictures, as we're working our way through the design, the code can start to be written. Well, then we get to the real virtual commissioning. And we've got two different varieties. There's a software in the loop variety and a hardware in the loop variety. We're going to look at these two in depth because we find that a lot of folks have questions about them. So the first, software in the loop. Now what this means is that the designing, planning, engineering, everything is on a laptop. It's software that's in the loop. We're using NX MCD, we're using the TIA portal, we're using PLC Sim Advanced. We're using all of these tools. Now these are Siemens tools, and they are certainly the best in class. How does this work? Well, let's kind of step through it. So first, we get a 3D model from CAD. You'll notice I didn't say a 3D model from NX Because if you use SolidWorks, AutoCAD, CATIA, Solid Edge, it doesn't matter. We're able to take that model and bring it right into NX MCD. And right from there, we're able to use it. It's kind of interesting to note that if you're using SolidWorks, you don't even have to step the files out because NX can open it without any problem. Once we open those files, now we have the NX MCD tool and it is up and ready to use. We then go ahead and start to add our physics to the model. We start to add sensors, conveyors, you name it. The next step would be using the totally integrated automation portal. Now, what's nice about this is we're able to have everything virtual. So our drives, safety, networking components, it's all right in the TIA portal. What ties it all together is another tool called PLC Sim Advanced. The reason this is the best in class solution is because everything is virtual. So that means that you can speed this simulation up as fast as you want. So you could run a month worth of simulations in a matter of hours. Why? Because it's all virtual. It's all on one laptop. So you could say that the software in the loop solution, this is the top of the line. Everything's together, it's all integrated, it's easy to use. That's the Siemens solution. And as we said, that's the best in class. But we might say, well, what if I don't use Siemens PLCs or Siemens controls? A lot of folks that we've spoken to, they've said that sometimes it's their customer that makes the call. And maybe they're using a competitive product. Maybe they're using Rockwell or Allen Bradley or Mitsubishi or anything like that. Well, that's okay. NX MCD still works and it works great. It's just that we would use what's called a hardware in the loop solution. Basically, we're going to have the NX MCD model, just like we had in the previous. We open up the file. We start running NX MCD, putting on all those physics and the conveyors and sensors and so on. Well, then we have a real PLC. So that's where it's the hardware. You can see it at the bottom right. This hardware, it's now in the loop. We use a OPC UA server, and that gets these two programs to talk to each other, and we're still able to have virtual commissioning. And this works great for any non-Siemens hardware. So this is the hardware in the loop solution. On the left, you can see a picture of it. Here we have NX MCD. We've got a Rockwell PLC. And in the background, you'll see we've got Rockwell Control Logics. So it works great. It's just that there are some limitations. It's not that where you can run multiple simulations at the same time, or that you can't have it work so quickly or so seamlessly, but it does work. Now here's a good example of that. I've got two videos, and really they're videos of the same part. It's just one is a software in the loops and the other one is hardware in the loop. You'll notice on both of them, we have a virtual HMI. But the one on the right, what we're actually showing, this is that Rockwell Control Logics. And the one on the left is we're using all Siemens products. It's kind of neat as you're looking, it's doing the exact same thing. We're getting the exact same simulation. The virtual commissioning, it's working for both, and it's working really well. So that is the two solutions that we have. So if you're not using a Siemens controller, have no fear. NX MCD is still the tool for you. The next thing we're going to do is look at an actual machine, and we're going to see how they were able to use MCD and to save that 33% of time. The first bullet point is key. this was not an NX file to start with. But like we said earlier, it doesn't matter. What this is it's a machine that's made to test bottles. The company that made it, they decided to make this one to showcase at different trade shows. You can see there's a lot of electronics. There's a lot of hardware that's going along with this. Think back though to those three phases that we talked about. It was concept, detail engineering, and then commissioning. Let's take a look at how they were able to use NX-MCD for concepting. Here you can see two concept models. Now in each case, those little red lines, those are actually sensors. It's measuring the height of the different bottles, measuring the location of the bottles, telling our head exactly what to do. What's really cool about this is they're able to check, are we able to keep up with multiple bottles at the same time? Or should we just use one bottle? And they're able to do all of this so quickly. Think about how much CAD time it would take to build these concepts. It wouldn't take much at all, would it? And yet, right from this concept stage, an automation engineer, he can begin thinking about his code and do more than that. He can begin writing it. What about when it comes to a detailed simulation? Well, here we've got the finished product, and we're able to actually see exactly what this machine is going to do. And you can see the power of this. Even one of the bottles with that physics engine, it fails, and so it drops right out of place. Next up will be the virtual commissioning. So let's take a look at this. And this little video is a little bit longer because there's a lot to it. So this is virtual commissioning using the Siemens solution. So we're using the TIA portal, PLC Sim Advanced, and this is the best-in-class solution using the best-in-class tools. What they're doing is just making sure that the signals, the tags are all lined up, and then we just launch that simulation. What's really nice about this setup, on the bottom right, you'll see we've got a virtual HMI. As we're pressing the button left and right, on the left, you'll see that head and how it moves. Or we can turn on the belt. We can make that move. This works the exact same way it would if you were standing in front of this machine holding the HMI in your hand. The advantage here is that there hasn't been any metal cut on this machine. So we're able to do all of our testing, our validation ahead of time. And here we can see changing what our HMI is doing, speeding up a conveyor, slowing it down, and so on. But this simulation, it's quite powerful, really, because it shows us all of the aspects of what we should expect to see. For example, if the door opened, you should see a safety warning, or you would on the real HMI. Guess what? You do see it on the virtual HMI as well. So we'll just take and close that door. And then just continue with our simulation. And then what happens if you hit this emergency stop? Well, you'd expect a warning to pop up on the HMI. And you get the same thing with the virtual HMI as well. Then we can test this and test it even to see what are the limits of this machine. Some that are using NX-MCD, they'll use this tool for training because they want to train the person using the machine, but they want to train them without them ruining the machine. Let's take a look at a couple of other things that NX-MCD can do for you. Here we can see just testing a tool change, something that should be rather simple, or a riskless test. I cringe every time I see that. How much did that cost if that was in real life? What about just testing something as simple as the axis transformation? Making sure that the machine is doing exactly what we want it to do. We can also incorporate limited use of robots. In this case, a pick and place. And also check for errors. And that's one of the keys. You'll notice in this that our tool, it's not lining up. And so we do a quick little measurement, and we can see that it's off by 19 millimeters, about 3/4 of an inch. With your eye, that could be difficult to see. And it could have been that the way you noticed it was by ruining something, but not with NXMCD. We're able to do that test and check for everything. Or even just the system behavior. When does the door open? When does the machine go in? Does it drop off the part exactly like we want? And then does it close? So what can MCD do for you? It can do a lot, and it can do so much more. As we had brought out, with MCD, we're able to save about 33% of our time when we start with the concept stage, all the way to detailed design, and then lastly with virtual commissioning. You can be a third ahead of everybody else. We're able to test out the machines, make sure that they're working. And in doing so, we can have mechanical, electrical, automation, they can all work together. And then as we said, having virtual commissioning, we can test our machine, test the code ahead of time to make sure that the machine that we're making, that it's going to do exactly what we want it to. We had a couple of nice little quotes of a company in Europe where they started to use this tool. And it's kind of interesting when you actually look at it. The first one from Eric, he says, when you do the design, production, assembly, then the software guy starts to program. In this case, he actually came out with a software, pushed the button, and it worked. No collisions. And then Tor, by playing with the virtual model, you can learn a lot. And doing that, it is fun. Doing that with the physical machine, that is not fun. That is scary. It's kind of interesting with some of the folks we've talked to about using this powerful NXMCD tool. They've said that the way they're doing it now is they have one guy and he is poised, sitting right by the e-stop button. And his job is just to hit that e-stop the first collision that they have. But how much is that going to cost? As you can imagine, it's going to cost a lot. With virtual commissioning, you can test that code and make sure there are no collisions, that there is no risk. And if you don't really want to travel to the far-flung corners of the earth, with virtual commissioning, it really cuts down on the amount of travel. As Eric said, everything worked right when he plugged it in. Push the button and everything was good. Well, that's going to conclude this high-level look at NXMCD. So we'd like to open it up to see if we have any questions. And if anyone would like to see any more, maybe you'd like to see that NXMCD tool in action. Well, then you can see my contact information on the bottom left. So do we have any questions?
Hey, Curtis, you're muted.
Sorry about that. So yeah, there is a couple of questions. Great presentation, by the way.
Thank you.
In fact, I learned a thing or two, which is nice. Anyways, what is the learning curve?
You know, it's such a powerful tool that you would think it's going to take a lot of time to get up to speed with this, but that's actually not the case. For one thing, it's fun to use. I know that sounds strange, but it is. It's enjoyable. And because it's fun, it makes that learning curve a lot less steep. But what we've done with some of our customers is we've simply done a 1-day workshop. That's right, we spend 1 day with them, showing them the basics of the tool. And then from that 1 day, they're able to hit the ground running. We then do a couple of little follow-ups just to answer any brief questions that they might have in the weeks preceding. And then lastly, we spend another half-day wrap-up, just helping them to take what they've done in MCD and hook it up to their machines.
Nice, nice. It sounds less complicated than I even thought. So if I want to do this, how do I get started? What's the first step? Because you talk about virtual commissioning, other things. What's the first step?
Well, the first step is our contact information. You can see it there on the bottom left, not to be real salesy, but we can take a deeper look at the tool and how it would work with your products. One customer that we spoke with, we took their model and we just put a few hours, I think I only spent 3 or 4 hours baking in some of the physics, the conveyors and so on. And from there, they were able to see that this tool would work for them. And that really made them pretty happy and excited. So I think that's the key. In the handouts, there's actually a fact sheet that talks more about this tool.
Great, great. Okay, so I have CATIA and we use NX. Do I have to do anything special to use the CATIA parts?
No, not at all. Really, you're just going to take the CATIA files and step them out right into NX. It's kind of interesting. The majority of models that I've worked on up to this point, they have been non-NX, and there hasn't really been any problems at all. And I'd just like to add, it's the same way if you're using hardware that's not Siemens. There's a solution for that, and it works great.